Welcome back. Sorry it's been a little while since I've put out a video. I had some family things come up in the United States, so I had to take a bit of an impromptu trip with the wife over there. But yeah, now I'm back. So I did find a few interesting bits of retro equipment while I was in the US, but couldn't really bring much of it back. The freight was the killer. One of the items I found, the freight price was between, it was the only estimate they gave me was between $500 and $2,500 US to ship an item back to Australia, and that item ballpark would have been about the size of an Osborne executive. So clearly the freight, the cost of the freight was way more than the cost of the item or the value of the item, so it clearly wasn't going to fly. But I did manage to bring one thing back with me in my suitcase. No, just kidding. No, I did bring that back, but that's not it. I brought back this, and of course it's still wrapped up because I haven't opened it yet. So I don't know. I brought it back in my baggage on the plane. A bit of spare space I had. I don't know how well it survived. It was packed pretty well in amongst a heap of clothes, so it should have survived. But in this video, we'll crack it open and we'll have a look. I won't tell you what it is. Some of you may have worked it out, but if you haven't, keep watching and all will become evident. Okay, so let's crack this open. I'll find my knife and see how well this survived the trip. This was in my carry. Oh, sorry, my carry. This was in my checked-in baggage for I think 4 flights. So it's been molested by baggage handlers at least 4 times. And there it be, a Commodore VIC-20. I've never actually owned one of these until now. Obviously coming from the United States, this will be the NTSC variant of the Commodore 64. And I didn't bring the power supply back with me. The power supply in this one is the original variant with the 2-prong connector, so it doesn't use the same power supply as the Commodore 64 does. It's a 9-volt AC input, and I didn't bring that power supply back. One, because it was heavy. It's just a transformer in a box, and it was pretty heavy. And it also looked like it had been getting pretty warm, and the plastic was sort of deformed a little bit, and it didn't look to be in the best of shape. And it was going to be a 110 volt transformer in there anyway. And in Australia we have 240 volt power. So it wasn't going to be particularly useful to me. But what I did do is I snipped the plug off that plugs into the computer. So I've got that bit, and I did actually build another power supply on the weekend, which I've got just over here. So we've got this this power supply. It's just a transformer in a box, power switch, and the original VIC-20, power plug there, and fused, of course. And that's, I've tested that. It's putting out 9 volts AC. Well, unloaded it's about 10, but it's safe enough to plug into this VIC-20. Okay, well the first thing to sort out is the video. So we've got the original VIC-20 video, I'm assuming it's the modulator here. We can select channel 3 and channel 4, and it's set to channel 3. That'll be channel 3 NTSC. So the 64 must go to that one. It's the only one it fits into. And then I've got to get that into this connection that my TV here accepts. So I've got a matching transformer here that'll take the 300 ohm in and output 75 ohms. And I'm just using the generic switch here that came with the VIC-20, more as a way of converting from the RCA to the screw terminals. That's really the only thing I'm using it for. And then we'll hook the RCA cable up to there, and the RCA cable up to the modulator. So we're going from the VIC-20 to the modulator to the switch to get it into our screw terminal, and then over to the TV. Right, so I've got a power cord now for my power supply for the VIC-20, and we will just check for the sake of completeness with the multimeter to see what voltage we're getting out. Of course, we'll put the multimeter into DC. We're getting nothing. Turn the power supply on. 9.28 volts. So that'll be plenty safe to plug into the VIC-20. Right, so plug the cable in. And turn it on. Now we'll turn the VIC-20 on. The power lead came on, so that's promising. I'll press source. And we're going to want to, I'm imagining, change this to America, which will hopefully give us the NTSC. We go auto store. Hopefully this will find our VIC-20 image. Oh, well, if I press start. I don't know what frequency channel 3 is, but 170 odd megahertz sounds a little high for channel 3, so maybe we've missed it. Right, well, that didn't work. The frequency for channel 3 NTSC is 56.15 and 67.3 megahertz. I'm not sure which one's the audio carrier and which one's the video carrier, but either way, it's down quite low. So we're just going to the menu again. Because the other catch is, I don't know whether this VIC-20 actually works. I believe it does, but I've not actually seen it work, so anything is possible. Right, so let's eliminate some things. We'll turn the VIC-20 off, and let's see if I can eliminate my RF cable, just in case it's the problem. And see if I can plug this directly into the antenna input in the back of the TV. And yes, I can. Okay, so I thought I'd put the oscilloscope on the video output and just see if we're getting a video signal. And we can see there I've just flicked it on, and we are getting a signal. It's about 1.5 volts by the look of it. Well, actually that's a bit over, I don't know where the 1.52 volts is coming from, but that's more like 2 point something. But I don't know, to me that doesn't look like a video signal, and I'm assuming I should be seeing composite video at this point because it's on the input to the modulator. So either the modulator is cooked somehow, or more likely we're just not getting a video signal out of the VIC-20 itself. So we might have to break it open and see what's going on. Okay, so we'll turn the machine off, disconnect the power for the moment. Now just connect the video. Just kill the oscilloscope because it's just noisy. And we'll just put this towel down on the bench just so the machine's not on the hard bench directly. Right, Now right, so I've never worked on a Commodore 64, a VIC-20 before, so this will be a new one for me. Looks like we've got the 3 screws at the front, which I've got to say weren't particularly tight, so I don't know whether that means someone's been in here before me. So, I think, do we have one under there? I don't think we do. No, it doesn't feel like it. So maybe, just get the lid lifts off. Okay. So a keyboard connector, we'll just disconnect that. And our heatsink's a little wonky. That may have shifted during shipping, I guess, but it was only spun round, so I can't imagine it would have appeared to have shorted anything. Pretty dodgy arrangement though. It must be screwed from the bottom of the PCB. So there could be any number of things not working here. Disconnect the power lid, we don't need that. I mean, we could have any of the standard sort of faults, you know, with the MOS chips, or maybe not. I guess we'll have to do a bit of a deep dive and see what's going on. As I noted earlier, this is one of the original versions of the VIC-20, the 2-pin power plug. So I don't know practically what difference that makes, but I guess we'll work our way through it. And I think, yeah, you can see the voltage regulator down in here, and this whole cartridge slot cover is basically a massive heatsink for that, and it does get warm. I'm not quite sure what this is the heatsink for. I don't know if there's a 5-volt regulator or something under there, or whether it's... There's something... Oh, bang. That could be a bridge rectifier under there. It looked like there was a 4-legged component in the rough shape of a bridge rectifier, so could well with that. I have no idea what this connector does. I guess we'll find out as we go. Now should we take the board out? These are all quite loose. There's no satisfying sort of crack noises. They come out of the plastic for the first time in their life, so maybe someone's been here. Yes, that's like a thread screw. Just can do a brass insert something. What was that? This was a bit last time. Also got a wooden skin. That's one like that. Feels good. We might have it. Maybe? Or is there another one hidden somewhere? It feels like there's something in that corner, but I don't see, oh, there we go. So I don't see anything in there. That's the bottom half of the case. The case isn't particularly yellowed. It's got a few scuff marks and things on it, but it's spent, I'd say, the most of the last 30-something years in a box. So it hasn't been attacked by the sunlight. Does that work? Yeah. And now we've got this RF shield on the bottom. Nice gold RF shield, which I'm guessing we're going to want to remove. I don't know, I haven't decided yet whether I'm in the camp, you know, the put the RF shield back camp, or whether I'm in the rip it off and throw it away camp. But I've got plenty of time to make that call. so let's check that we're getting voltages in the places we expect to get them in. Because obviously if we're getting no voltages in the right place, well, nothing's going to happen. So untangle my multimeter leads. You wireless multimeter leads would be nice, eh? So we'll go for a ground, and let's start with, well, we'll look over this side of the board. And we go to DC. Turn it on. 5.04 volts on a RAM chip over here. We'll just pick a few at random. 5.04. I can't remember what pins VCC on the 6502, but we're getting 5 volts anyway, and we're getting it on this side of the board. So that's probably a fairly good. Well, first of all, let's just check the voltage on the VIC chip, which is on pin 40 apparently. 5 volts. Yep, exactly what we'd expect. 6502 is on pin, I think it looks like an 8. 1, 2, 3, 4, 5, 6, 7, 8. 5.07 volts. Yeah, so we've got sort of voltages where we'd expect them. Right, so going into our VIC chip, we should have a clock signal going in on 38 and 39. So there's 38. That's just right, and we've got about a 5 volt clock signal going at 38. Same thing on 39. So we're getting clock into the VIC. Let's see if we're getting a clock over at the CPU. CPU's clock looks to be on pin 37. So move our earth over. Pin 37, so 40, 39, 38, 37. And this is going to be scaled down. See, the oscilloscope's telling us we've got 1.0227 megahertz, which is I think about right, and about a 5 volt square wave. So that's looking promising. We'll check our reset line, pin 40, just make sure our reset line's not stuck low, and our reset line is high, so it's an active low signal. So if that was low, the processor would be stuck in reset, and that is not the case. So we're not stuck in reset. We'll go up to pin 6. 1, 2, 3, 4, 5, which is the non-maskable interrupt, also active low. So because it's high, we don't have any non-maskable interrupts. And IRQ is on pin 4. Right, we do have some activity there. And the frequency of that is 60.03 Hertz. So I don't know the VIC-20 well, but I'd speculate that there's probably an interrupt being generated once per frame, because the frame rate of the video is 60 Hertz, being NTSC. So I would be guessing that's a vertical refresh interrupt. So that's all looking promising. We'll have a quick scan of the address bus just to see what it looks like it might be doing. So we'll go, I'll start at 33, so 40, 39, 38, 37, 36, 35, 31. Right, so we do have activity on that address line, and that, oh sorry, that's data line, so that's data line 0, data line 1, data line, get it on there, data line, where am I, 40, 39, 38, 37, 36, 35, 34, 33, 32, 31. So there's no activity on data line 2, which is odd. It's kind of stuck high. What? Oh, maybe I crashed it when I slipped off that pin. Let's try that again. Right, so we've got data there, data there, data there, data there. 26, yeah. So the data bus is doing the business. So that's good. 1, 2, 3, 4, 5, 6, 7, 8, 9. So address bus, this is address line 0. Okay, I don't know quite what's going on there with those slightly higher levels there. You can see over here we're sort of around 4 volts and we're peaking at 6. It's almost like something else might be driving the bus. Yeah, we've got a little bit of oddness happening here as well. Yeah, I mean, these are the higher address lines. It could just be stuck in a tight loop. No, I'm not convinced about these signals. 19, 18, 76, that's 16. So that's address line 7. I mean, as I said before, it could be stuck in a really tight loop, waiting for something to happen, like polling, waiting for something to happen, but which could explain why some of the upper order address lines are not changing. So I don't know that's necessarily a bad thing just yet. But anyway, we do have some activity. We've got to be mindful that this bridge rectifier gets a bit warm without its heatsink on. So far so good. We're not stuck in reset. We're not permanently in an interrupt state. We've got activity on the data bus, some activity on the address bus, which might suggest that we're in a tight loop somewhere, but that's, I'm guessing, not entirely unexpected. So we'll try a couple of other things here in a second. Okay, so I did have a chat online to the people in the VIC-20 Facebook group, and one of the suggestions they had was to see if the CPU was alive by plugging in the cassette recorder, which I just so happen to have right here. So we can, VIC-20's turned off, so we can plug this in. And the theory is that if I blind type, once I plug the keyboard back in, if I blind type the load command, it should make the data set start. And when I press run stop, it should make it stop, which would confirm that at least the processor is talking via the CIAs to the keyboard and it's driving the cassette motor output. So we'll give that a go. So we'll turn it back on. Just wait for it to do the normal things it does. We go load, press play, and the cassette plays. Now if I press run stop, the cassette stops. Load again, cassette starts. Run stop, cassette stops. So the lights might not be on, but it does look like someone is home because it's responding to the keyboard input and starting and stopping the tape motor in response to that input. So fairly good sign that at least there is some life here, and yeah, we'll keep digging. So next I'm going to try see if I can get any sound out of it just by blind typing some poke commands to generate some sound, and we'll see how we go with that. Okay, so I've got rid of the data set, and according to the schematics here, we should be seeing sound out on pin 19 of the VIC chip, if I'm reading that right. So we'll go ground up, and we'll connect up to pin 19, which should be the last pin down the end here. Hooked up to that, and we should be able to turn it on. Do a poke 36878, 5, poke 36877, 128. Now we won't hear anything because we don't have a speaker, but I would have expected to see something on the audio output pin of the VIC chip. And if I change the scale on the scope, we're just getting very, very low level noise, like 10/10 of stuff all. Okay, here we go. 36878 is the volume. 36877 is noise. Right, there we go. Poke 36878, 15, which apparently is full tilt. And poke 36877, 128. Nada. Yeah, so I should be getting sound according to the documentation, and I am not. So something is happening either with the VIC chip itself, with the circuitry surrounding it, or with the logic between the processor and the VIC chip. So I think that's where we have to dig next. Okay, so looking at this, we've got our processor over here on the left, we've got our VIC chip over here in the middle, and the VIC chip is fed by some buffered, I don't know whether that says YA or VA, but in any case they're coming out of these 65245 chips here, which I imagine are the same as the 74245, and it's also fed by buffered data lines which are coming out of another 65245 at the top here, again another 74245 sort of equivalent integrated circuit. So at the moment my prime suspects, given that we seem to have an issue with our processor talking to our VIC chip, is these 65245 chips that sit in the middle between them. So let's have a bit of a poke with the oscilloscope and see if the signals we're putting into these bus transceivers are the same signals we're getting back out of them. Let's hook our ground pins up. Right, and let's have a look. So we'll start with UD8, which is the lower order address bus. So we're going in on pin 2, and pin 2 corresponds to pin 18 on the output. And as with most things, when you turn them on, they do tend to work better. Scale here, that's as good as any. So if we look at the output, I keep slipping off them. So our output is pretty much the same signal, just delayed by, what's that, 250 nanoseconds or something, which would be the propagation delay of the chip. So work our way along. Yeah, I'm not quite sure why that input signal on address line 1 is sort of peaking like that, but anyway, what's going out? Yeah. Yep. Yep. So just work our way along and just check that things are sort of what they should be. And the levels are a little bit interesting, but otherwise, so now we'll go to UE8, which is the higher order address lines, and there's also, looks like a colour line, quite sure what that's driving, and some sort of clock going through there as well. Now these 245s, even though they can operate in both directions, pin 1 is hardwired to 5 volts, so these are only actually operating in the one direction, which for an address bus is fine. Because the processor asserts signals onto the address bus, it doesn't need to get anything back off the address bus. You know what all that sort of slow ramp up there is on the output. It's a bit strange, but anyway. Okie dokie. So we're mostly low on the input. And we're getting these little spikes with occasional activity. So the lines being predominantly low could just mean that we're not, the processor's not operating in that area of address space, so that in itself is not a problem. Right, and then on pin, where are we? 1, 2, 3, 4, pin 7, we have a colour signal. 1, 2, 3, 4, 5, 6, yeah, pin 7. And pin 7 should correspond to 13, 8, 9, 10, yeah it does. Now, interestingly, we seem to have a 1.02 megahertz signal gain, which is coincidentally the processor's clock speed. Am I looking at the right chip? UE8. Yeah, UE8. Pin 7 is a colour. Right, so in any case, what's going in the input side of this chip is not coming out the output side. Sorry, I get that wrong. The blue trace is what's going in the input, and the yellow is what's coming out the output. So there's a signal coming out the output that shouldn't be there. And then the next signal is a clock signal. What? UE8. UE8. Pin 1, 2, 3, 4, 5, 6, pin 8. Supposedly a clock signal of some description. I'm confused. Pin 9. Now pin 9 is supposed to be the CPU's write signal according to the schematic, read-write signal according to the schematic I've got. And that is, looks to be sitting at about 2 volts. What the? And yet if I look at the CPU's read-write signal on pin 34 of the CPU, 40, 39, 38, 37, 36, 35. So there's the read-write signal. And that doesn't appear to be making it to the input of UE8. That's interesting. And that should also be at pin 1 of UF8. So pin 1 of UF8. So there's our first problem. The CPU read-write's not making it to pin 9 of UE8. So either my circuit board has a fault or my schematic is wrong. So that's the first thing to look at. Now I'll just go to the next chip, which is UF8. And again, we'll work our way along. Now this is bidirectional, this one. What the hell is going on there? So noteworthy here is that this chip is being used backwards. So the input is on pin 18, which is looking cleanish, and the output is on pin 2. Presumably they've done that to avoid having to put an inverter on the direction pin. But yeah, it's just crap. Like, that's not right. And that's looking better. That's looking better. Looking better. Looking better. So it's pins 2, 3, 4, 5 on that chip. 2, 3, 4, 5 correspond to the buffer data line 0, 1, 2, 3. And yeah, we're just getting crap. It's all over the place. And those buffer data lines are what feeds into the VIC chip. So we appear to have a couple of issues. One of them being that the CPU's read-write signal isn't making it to pin 9 of UE8. So I've just got to validate that it's supposed to be, because this schematic might not be the right one for this board. I think it is, but could be wrong. And the other problem is the output of pins 2, 3, 4 and 5 on UF8, the data bus buffer, is just crap. It's crap everywhere. So something on that buffered data bus is causing grief. I don't know if it's the VIC chip, I don't know if it's the buffer itself, but it's only the 4 bits, and coincidentally the RAM is 4 bits wide, so it could be a RAM chip, because BD0123 are connected to all of the UD RAM chips. So that's all of these ones. That one, that one, that one, that one, and that one are all connected to those data bus pins that are spewing garbage. So I guess theoretically it could be any of these chips that's causing the problem. It could be UD7. UD7 is a ROM, but where is UD7? Is it? Oh, that's the character ROM, so it could be that, because that's connected to that bus. The basic and kernel ROMs are connected directly to the CPU bus, so it won't be those because they're not connected to the buffered data bus. And as we said, it could be the VIC chip, because that is connected to the buffered data bus. What else have we got? What else is connected to it? And the CIAs are connected to the buffered data bus. And that in itself is interesting, because we were able to use the keyboard to type in a load command, use the keyboard to hit run stop, and that was causing the cassette motor to start and stop. Well, the keyboard is connected to this CIA at the top, so that must be working to some degree. So this bus can't be totally wedged up, otherwise that wouldn't be working. And the cassette motor output is on the other CIA, so that must be working to a degree. So this, whatever's happening on the buffered data bus is intermittent. Well, intermittent, it's consistent, but it's not happening 100% of the time. So it may only be occurring when certain chips are selected. I suppose the obvious thing to do, we can take the character ROM out, we can take the CIAs out because the machine will still boot without them, and see if we're still getting the same gibberish on the buffered data bus. I suspect we will be, but we'll give that a go. Right, so we've turned it off, and we'll take our character ROM out. Right, so let's see if we're still getting the same gibberish on the output side of UF8. Yes, we are. This is the first 4 with the gibberish on them, and then this one, still not perfectly clean, but it's it's a whole lot cleaner than this mess we're getting here with levels that are just wrong. So I actually wonder if it's a chip that's just not driving the bus properly. Don't know. We will find out in due course. So at this point, I can't guarantee our CIAs and our character ROM are working properly, but at least they're not causing the problem because they're not physically installed in the board. So that's leaving me with the VIC chip, which is obviously still in the board, because if I take that out, the processor doesn't get a clock, so I don't have much choice but to leave that in there. And the other standout thing that's connected to the buffered data bus are all of these 2114 RAM chips. Now because we've only got this crap on D03D3, we only have to look at half of these RAM chips because the other half are on the other data lines. So as I said before, we're looking at the ones in the D row. So these ones are going to be, these are the suspect ones in here. Now I did have a thought that maybe our 74LS138 might have a problem, and maybe it was putting two different RAM chips on the bus at the same time, but that doesn't match what we're seeing. If that was the case, then we would be seeing a similar issue with BD4 through to BD7, because we'd have two of the upper chips on the bus at the same time as well as the two lower chips. So I don't think the 74LS138 is the problem. I did a little bit of sleuthing on the CPU read-write that was supposedly going through one of the 245 buffer chips. As it turns out, there's a variation between my circuit board and the schematics that I've got. So I've got the schematics for board revision 324003. I found the only schematics I found are for 324001, but as it turns out, there's two different versions of the schematics for 324001, and one of them, the one I've been working off, shows the CPU's read-write pin being buffered by UE8, and the other one shows, the other revision of the circuit shows that not being the case, and it's actually going through some logic gates. And that's the version of the board I've got. So that settles that. The 245 isn't supposed to be buffering the CPU's read-write signal on this revision of the board. So I was having a little bit of a fiddle with the VIC-20 this afternoon, just off camera, just having a bit of a poke and a prod to see what I could work out. And I thought from what I was seeing that the 4066, which controls part of the memory access, might have been faulty. It just didn't look like it was sort of behaving the way I'd expect it to. So I desoldered that and put a socket in. I don't have a replacement 4066 handy. I've got a lot of other things, but not a 4066. But I did put the 4066 in the Torntech tester I've got, and it tested fine. I put it in the Mini Pro, it tested fine. So, is the 4066 the problem? Maybe it's not. I do have some more 2114 RAM on the way. That's probably another week or two before it gets here. I don't know if the RAM is the problem, but I figured it was handy to have some anyway, because I've got some other bits and pieces I want to play with that use that RAM. So I think for now, I'm just going to finish this video here. There's obviously going to be at least a part 2 to this, where we investigate further. But if anyone's got any great ideas of things I should try, then yeah, drop it down in the comments, because I'd love to hear your opinions on what other things I can do with what I've got to try and diagnose this. I don't have a diagnostic cartridge for the VIC-20. I have ordered a circuit board to make one, but of course the problem with making a diagnostic cartridge is, once I've built it, how do I know it works without having a working VIC-20 to test it and prove that the cartridge works? You know, it's a bit of a catch-22. So I could end up going down going on a bit of a wild goose chase there if I'm not careful. But anyway, I'll ponder it some more. I'll wait for some parts to arrive, and yeah, and then we'll kick off with part 2. And as I say, if you've got any great ideas, things I should try, things that are likely culprits, whack them in the comments because I'd love to hear it. And until then, I'll see you next time. Cheers.